I'm R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we will see the topic Dielectrics and Polarization for the unit Dielectrics and Steady Electric Current. So first we should understand the concept behind the dielectrics. In order to compare with dielectrics, we must know about conductors. So conductors have large number of free electrons while dielectrics do not have free charges. The charges in dielectrics are bound by finite forces, hence they are called as bound charges. As they are bound, they cannot contribute to conduction process. But if subjected to an electric field E vector, they shift their relative positions. So this shift in their relative positions of bound charges allows dielectrics to store energy. So next, a very important concept in dielectrics and polarization is the polarization. The shift in positive and negative charges are in opposite directions. So under the influence of an applied electric field E, such charges act like small electric dipoles. So these electric dipoles produce an electric field which opposes the externally applied electric field. So this process, due to which the separation of bound charges results to produce electric dipoles under the influence of electric field E, is called the polarization. So the diagram explains the unpolarized atom of a dielectric. So we have a positively charged nucleus at the center, and negatively charged electron is at the outside. And here when E is equal to 0, that is no electric field is applied, the number of positive and negative charges are equal and the atom is said to be equally electrically neutral. Both positive and negative charges are considered as point charges of equal amount coinciding at the center. So thus there is no existence of dipoles. So this is called as unpolarized atom. Now the polarized atom of a dielectric is obtained when the electric field E is applied to its atom. So when the electric field is applied, what happens is the symmetrical distribution of charges get disturbed. So positive charges experienced a force F is equal to QE, and the negative charge experienced a force F is equal to minus QE, that is opposite force in the opposite direction. So thus there is a separation between nucleus and the center of electron cloud. Such an atom is called polarized atom, and the mathematical expression of polarization is given by P is equal to Q into D. So here D is the distance vector from minus Q to plus Q of the dipole as shown in figure. If there are n dipoles in a volume del V of the dielectric, the total dipole moment due to electric field is Q1 D1 plus Q2 D2 up to Qn Dn. It is equal to summation I is equal to 1 to n Qi Di. As a measure of intensity of the polarization, we define polarization P in coulombs per meter square as the dipole moment per unit volume of the dielectric. That is, P is equal to limit del tends to 0, summation I is equal to 1 to n Q1 D1 by del V. So mathematically, rho V can be obtained by del dot epsilon naught E minus rho V. So this can be written as del dot epsilon naught E plus P, polarization P, or it is also denoted as del dot D. We know D is the displacement density vector, it is epsilon naught E plus P, and the polarization P is equal to x E epsilon naught E. So this x E known as electric susceptibility of the material and is more or less a measure of how susceptible or sensitive a given dielectric to electric fields. and D can be written as epsilon naught epsilon r E, or D is epsilon E. So by comparing these two equations, epsilon, the permittivity is epsilon naught epsilon r, or the relative permittivity epsilon r is 1 plus xr is equal to epsilon by epsilon naught. So the problem is find the magnitude of D vector and P vector for a dielectric material in which the epsilon value is 0.15 millivolts per meter and Xc is equal to 4.25. So for a dielectric medium, D can be given as epsilon naught epsilon r E, and D is given by 6.9729 into 10 power minus 19 coulomb per meter square, and the polarization is Xe x naught epsilon naught E, and it is given by 8.644 into 10 power minus 10 coulombs per meter square. Thank you.